Let's go!
Right, so hello again guys, this is me again, Engineer Gaming for another episode of solving homogeneous DE examples. Alright, so previously I uploaded a video in regards to homogeneous, which is the first example that I've actually uploaded, so might as well check it out before you check out this example because this one is a little bit lengthy than the other one. Alright, so we have here the example. X minus 2y dx plus plus 2x plus y dy. All right, equals 0, of course. So once again, there are the only two terms that you need to remember, the m and the n. So over here, we observe that both terms are actually quite the same. Both are actually simple. So actually, if both are having the same or like their terms are actually simple as well, then we will be using or preferably using the n. Okay, but it's up to you because you can also use m since it will be actually having the same answer. All right, so let's just use the n only. All right, let's copy paste this one. All right, there you go. Let's cancel out that, put it here. Why is it like this naman for a while? Okay, there we go. All right. So once again, since we're choosing n, all we need to do is simply or all we need to do is to substitute all y into vx. So all letter y will be changed into vx. And then all the dy will be substituting this one, v dx or the derivation of y, v dx plus x dv. All right. The next thing we would do is, actually on this part, we can actually factor out x on both terms, right? Okay, this one I'm gonna put a parenthesis on this one. So that, oops, not the way that I wanted it. There. Okay, so we're gonna be copying this one again. Boom. And then x will be factored out over here. So this one should be 1, and this one should be 2b only. While on the other side, x will be factored out as well, 2 plus b. And then, what you need, which means we can now cancel out x in both terms by multiplying all sides by the fraction for a while. The fraction 1 over x. Then of course that will be canceling out the x, and we will be left with these terms 1 minus 2b dx and this term. Right, let's copy that one. Maybe we just gonna copy this one. I think it will be simpler. Cancel x, cancel x. All right, the next thing we would do is distribute all the dx over here and this one by FOIL method, so that we could actually get all the combination of the like terms. So this one is a little bit tricky, and sometimes a lot of students are being confused with it since there's a lot of variables involved. So all you need to do is you have a patience on answering this one so that you'll get the right term. Okay, maybe we can just insert a new so that we'll be doing it the right way. So we will be having here dx minus, let's put it over, I know it's okay not to put it in a parenthesis, 2b dx plus, okay, FOIL method, this is 2b dx plus 2b dx, okay, first term to first term, then first term to last term, so plus 2x dv, and then the second term and the first term, v squared, oops, it's dx, and then plus the last one, second and the last term, which is Vx dv equals 0. All right. Now, are there any like terms? Yes, apparently there is this one, right? So beyond that, we can actually cancel this, no? Let's highlight that with red. We can actually cancel out that. So we'll be remaining, or we'll be having this one only. Copy that, and then we'll be having this one. So all the dx must be merged, while all the dv must be merged. So we can actually rewrite this one as, okay, so dv is over here, so we can actually transfer this one over here. Control C, boom. Then we'll just delete it. All right, so now dx and dx are already in paired, and this one as well. But they also have this term. So all we need to do is factor out dx on this one and factor out dv on this one. So I will do that. Copy this one. All right. So of course, we factor out dv on this one. We'll be left with 1 since we factor out the 1 dx plus p squared. Right, and then there you have it. Then over here, of course, we're going to be factor out dv since both terms have dv. Okay? So this would become, we will delete dv, and that's it. Okay. There. Actually, there's still also x, no? So let's factor out that one as well. There you have it. And now, what can you observe? Yes, this can be separable. So this one, it's okay for you not to transpose it since this one is already in the positive sign. So we can actually direct this one as by separating those variables so that we can pair v to dv and x to dx. X to dx. Here. Okay? So how do we do that? Let's copy paste this one first. All right. The first thing we need to do, multiply both sides once again by this one, the fraction. So once again, why is it fraction? Why is it not just the linear, just this one? Because you cannot cancel this one once. You cannot, if you won't be multiplying this one in a denominator side. So that's why we'll be putting 1 over this one, the term 1 plus v squared. And then this one also the x, because we need to transpose x to the x side. So that's why we'll be transposing x, oops, not deleting x, over here. There we go. Then cancellation, we'll be canceling here the 1 plus v squared, and the only thing that will be remaining is the over x. How do we do that? Okay. Insert equation, fraction, and then this will be dx left, x, and equal, plus rather, this one, no? This one. But of course, v has actually being transferred and removed from this term. And we'll be left with the denominator of 1 plus v squared. Of course, don't forget equals 0. Now this one can be integrated already because x and dx are paired and v and dv are paired. All right. Let's insert now the integration there. And then this term only. Copy. Boom. And then equals 0 because integration 0 is just simply 0. There. Okay. So this one, all we need to do is integrate each, no? So let's separate each, no? Para hindi tayo malilito. Okay. Insert equation integral of this one, right? Plus, since we have plus here, plus the integral of this one. Now, how will you integrate this one? So since in the numerator side we have a plus sign, we can actually decompose it into two fractions. So how do we do that? Okay, focus on this one, okay? Focus on this one. So let's copy paste everything. And then paste. And then since we decompose everything, this one would be left with 2. 2dv over 1 plus v squared. Plus, oh, that's shortened. What happened? Okay, plus, okay, there we go. The integration of same, this one. Oops, why is it not working anymore? There. But the other side, the v. All right, now we can integrate each term. This one, this is very simple. Once again, this is just 1 over x, so you can just get it as ln x. This one also, you can get it by use substitution. But this one is actually a trig substitution. But this one, we can actually, move out 2 on the outside of the integral so that we will be left with 1 over 1 plus v squared. And this one has already a fixed formula, but I'll be teaching you how to get that one. No, we will doing this step by step by step. Okay, let's focus on this one first, no, because that's one easy. So let's insert equation. Integration of dx over x is simply as ln x. Okay, that's it. Plus, okay, we'll be remaining this one as it is muna. Plus this one muna. Okay, so let's focus on this one first. Copy. Then let's move over here. Tab, tab, tab. Paste. And then equals. Okay. So we will be dealing with this one with u substitutions. If we put let u equals 1 plus v squared, that should, and du is equals to what? 2v dv. And since we have an integrating factor of 2, we'll be transposing it to the other side. So we will be having a neutralizing factor. I'm finding the arrow there. So nf is equals to 1 over 2. Right? Let's put the fraction in. 1 over 2. Okay? So therefore, 1 over 2 du, therefore 1 over 2 du is equals to b dv. Right? So now we have everything inside. So we can now put this 1/2 out of here. No? So let's transpose it over here. Oh, sorry about that. And then over here, and then over here we're gonna be putting another one. Okay. Then over here, since we already have this one, so we could have insert equation, the integral of, oops, sorry about that. Equation, the integral of b dv, that would be du, since over here on the outside will be moving out now the constant already. Okay, du over u. Simply this would become 1/2. Let me do this one. Oh, we can. 1/2 ln u, wherein ru is equals to 1/2 ln, the value of u, which is this one, 1 plus v squared. Right? So we already have now the integration rather of this one. Now let's focus on this one, because this one is a little bit on the confusing part. Okay, over here. Let's zoom in a little bit because once again the font shrinks. Alright, so the first thing we need to do is, of course, move out the constant to the integrand because that's not included. Equals to the integral of dv over 1 plus v squared. All right, now that we have that, you know that this one can also be written as v squared plus 1, which is in terms of a u squared plus b plus a, oops, let's see what's happening, a squared. Okay, now in this trig substitution, we all know that u squared plus a squared is equals to a tan theta. Okay, I'm finding the theta. Do we have a theta here? There, we do have a theta. Okay, so, oh yeah, I forgot, u equals a tan theta. So this is our major formula to use. Okay, now we need to check all the marks first. Okay, so we need to find the value of u and a, which is our u is simply this one, v, because it's raised by 2, and this one can also be raised by 2 since 1 squared is still equal to 1. Okay, so our value of u once again is v. That's why it's v over here. V equals, now our a here is only 1. Why? Because if 1 squared, still 1. So that's why even though it says squared over there, it's right, even though it says squared over there, still it will become 1. Let's say we have 1, so we'll just make it as it is, tan theta. Theta is too far away, damn it. There we go. All right, then we also be needing, what else do we need? The derivation of v, which is, let's move over here a little bit. Okay, the derivation of v, what is the derivation of v? Simply as sec squared, where is it? Sec squared theta. Okay, now that we have the derivation of tan, we also need to find what is tan theta, simply as over here, tan theta equals b, or tan theta is equals b over 1. Now that is crucial when we'll be having, or we'll be dealing with the right triangle. Okay, I think this one is good. Okay, here. Okay, let's move it over here. There. Okay, I won't be, okay, let's just insert text box. No, the simple text box over there. Okay, so of course we have tan theta is equals to v over 1, and tan theta in SOHCAHTOA, that is TOA, which means to wa. So to, opposite, which is over here, no, opposite, and then I mean, if we have our angle over this here, this would be our opposite. No, this one is actually like an isosceles. That's why it cannot. Let's find another one though. I think there's no right triangle. Let's just work with this one. So let's just visualize that this one is the opposite side. Okay, so the opposite side now is b. Okay, it's there. So the opposite side has v. Okay, and then the adjacent side. So why adjacent? Once again, it's to wa. So opposite, adjacent. Our adjacent is 1. And then simply, our hypotenuse is simply as, our hypotenuse is at square root of what? B squared, or 1 squared plus b squared. Right? Okay, we can actually just shrink it out. Okay. Oh, why there is something over there? Again. 1 plus b 1 squared. There we go. Okay, so that's all the components that we need. Okay, now that if I do this, I can actually just make this one, no? So that's all of our drawings, no? So if we put here, okay, there. Okay, and then we're gonna move this one over here now, so that we can have this side back. Okay, there. So now we have this one. We can say that, let's insert some equation. Now we can say that cosine of theta, cosine, huh? Cosine of theta, where's the theta? There. Cosine of theta is equals to, what is cosine of theta? That is ka. So that is adjacent, 1 adjacent over the hypotenuse, which is 1 plus b squared. Oy, bakit naman yan siyang, oh, there. And then, move, then equals. Okay. So, I guess hindi natin yun siya mapo-fraction form. So, I guess let's write it again na lang, for you to understand it very, very well. That will be 1, and then this one. Now, what's happening? Oh, we cannot, okay. And then, there. Now, we cannot use cosine in substitution of tan theta since they're not connected to each other. So, we need to find the sec. And we can actually get the sec by reciprocating this one. So, this would become sec squared, sec theta rather, sorry. Sec theta is equals to the reciprocal of that one, which is simply this equation. Now, we don't have square root of 1 plus b squared over here. So all we need to do is just simply square this one so that we can cancel out the square root. So what equation do we have now? That would be sec squared equals this equation over here without the radical sign, since it is cancelled or removed by the squared. Right. Now that we have sec squared already, or we have the value now of 1 plus b squared, which is this, no, this one, and then we also have the value of dv already, then we can use this to use the trig substitution. Okay, so I'll be putting this one for a while, plus I'll be transferring this one over here so that we can have an amazing, okay, then we're transferring this one as well, and this one as well. Okay, when that's transferred, we can now resume to this one. Right, so over here, we can now be back to this one. No, we'll be back to this one. Actually, this one. Okay, but this one, since we have 1 squared, oh, there's an S there. So we have 1 squared plus b squared, which is equal to sec squared, and dv of sec squared theta. Then we're just gonna write, oops, I forgot here, d theta. Where's it? D theta. Right. So let's just tap, or we cannot do that. And then we're just gonna lower it. There. So now that we have sec squared theta d theta, that will be substituted over here. dv, because dv once again is this one, okay? So we're just substituting there. And then over to that, the denominator, we have actually that value as sec squared. I forgot again the theta, I'm sorry. There. And then transfer it over here. So simple cancellation, sec squared theta, sec squared theta. Since it's in fraction form, then we can just simply cancel it. So we can only have the integral of d theta. Now, what's the integral of d theta, guys? Simply as, you're correct, simply as 2 theta. All right. Now, what is theta? We don't have theta man. Simple. Theta over here, we can just simply do the arctan. So, theta is equals to, you transfer tan to the other side by making it arctan or arctan V. And then that's it. Let's make it smaller again. There. Now that we have the value of theta, we'll just substitute the value of theta over here. So that would be 2, 2 arctan V. All right, now we have the integration of this one and the integration of this one. We're just going to pull it all together. So over here we have 2, because this one, the integration of this one is 2 arctan V, and then this one as well, 1/2, this one, 1/2 ln, oh wait, why can't I copy paste this? There, 1/2 ln v squared theta. All right, equals, since 0 is over the left side, and we all know that in plus c, it should be at the right side. So are we done? Actually, there are a lot of professors, or some of the professors still require this one to simplify, but actually this is an acceptable answer. But for me, it is good that we simplify it furthermore. So how do we simplify it furthermore? So our goal in simplification is to make sure that there is no coefficient that is fraction form. So all we need to do here is to multiply it by 2, so that this one would be cancelled. Okay, so what will happen? Let's copy paste this one again. Yeah, that one. That's the correct one. Uy, that's not what I wanted. It's this one. Right, so 2 times ln x simply as 2 ln x. 2 times 2 is 4 arctan v. And 1/2 times 2 is simply nothing. And then this one could be 2c. Now we have a lot of, in terms of other as well, in some other books, they usually denote this one as still as c, or wherein 2c is still c. But in some of their books, they actually do this one. 2c is equals to c sub 1. Can we do sub 1? We can. I thought we can't. C sub 1. Okay, so we're just using this one because some of the professors required what are the real value of the c. But otherwise, this one is also usable. So we can change this one as c1. All right. Now after that, we're left with this one. Can we still simplify it? Yes. Now this one, as you know in the laws of logarithm, this one could be raised as the exponent of the x, right? Okay, let's do that one. So since this one squared can be an exponent of x, this should be ln x squared. Simple as that. Okay, now can we still simplify? Yes, another laws of logarithmic. This one and this one are in plus sign, which means we can actually merge them one as one and then multiply it. So how do we do that? So when we merge this one, that will be, and let's copy this one again, ln x squared multiply by 1 plus v squared. Oops, v squared. Now is this done? Not yet, of course, since we still have the value of v, not in terms of y and x. So all we need to do is go back to this formula again, and then find the value of v. So what's the value of v? Equals, simply as y over x. Very good. Now, since we have y over x over here, then we're just gonna simply do this one, y over x, and then squared. Whoops, y over x squared. There you go. And then over here, arctan, simply y over x. There. Now, is this done? Some of the books, they said this is actually good. But still, in some of their books or some of their sources, they still simplified this one. How? Okay, let's do it, okay? Every step, every step. Let's do it. So this one, of course, we can actually distribute it on both numerator and denominator. So that would be, let's cancel the squared. No? Can we cancel it? We can, okay. So that would be y squared and then over x squared. Okay, there. And then this one, of course, we can merge these two, no, by adding both with their common denominator. Okay, how do we do that? Let's copy this one again. Okay, so this one, let's make this into fraction only, no? Para hindi tayo malito. Our common denominator is simply as x squared. Now, x squared divided by 1 is x squared, of course. X squared. And then this one, x squared divided by x squared plus 1 plus y times y squared. That would be plus y squared. All right. Now, after that, this one, x squared, and over here, x squared, can be cancelled out. So, what are we left? So, we are left with, let's copy this one. Right. So we'll be out, or this one should be cancelled, and this one should be cancelled, which will be left with x squared plus y squared. That's it. So this is our general solution. Right. ln, the quantity of x squared plus y squared plus 4 arctan y over x equals, of course, c. So this one can be also denoted as only C. And this one is still a, wait, not this one. Okay, this one is still a general solution since there's no boundary given. All right, so I know that's quite lengthy, no? But hopefully that you've learned and follow out my solution and the way I solve. And I think this is this part of lesson is very lengthy in solution as well. So anyways, this is the final answer and we actually get it. So I think that ends my episode of solving homogeneous D once again, and I'll see you guys next time. Like and follow for more.